This is the 9-4 review page for quiz 9-4 to 9-6. So we are looking at projectiles or things being launched upward, and we have this equation that all of this will apply to. So the height of the object or whatever we're talking about is equal to negative g, and g is the gravity, the pull of the gravity. And we talk about this in either feet or meters, and we'll come back to that in a second, times t squared, t in seconds, plus v times t. Now v has a subset of 0, and we know that means initial, so the starting velocity, which is like speed, times the time in seconds, plus h with the subset 0, that's the initial or the starting height. So number one, a cat leaps from the ground with an initial velocity of 13 feet per second. So it's from the ground. Okay, so since it's from the ground, that means the initial height is 0. The initial velocity is 13. And since we're talking about feet, the g is going to be 16. So what is the value of g? We're going to say negative 16. If it was meters, it would be negative 4.9. What's the initial height? So the height, we said, since it's on the ground, is 0. And now we're going to go ahead and write this equation. So h equals negative 16 t squared plus initial velocity of 13 times t plus 0. Now I'm not going to write the plus 0, but you would have a plus 0 there. All right, so how high in the air is the cat after 0.5 seconds? So we're going to go ahead and plug in for t here. H equals negative 16 times 0.05 squared plus 13 times 0.05. And you can run that all the way through your calculator just like that. Final answer, h equals 2.5 feet. Now, is the cat still in the air after 1 second? So what we're going to do is we're going to go ahead and plug in 1 and see what we get. And when I go ahead and I run that through, I'm going to get h equals negative 3. So I got a negative number, which represents something below ground. And in this case, the ground will be 0, and we're not going to fall below ground. And so is the cat still in the air? We would say no, and your explanation is the height is negative. If it was 0 on the dot, that means it just hit the ground. Negative means it hit the ground in the past. Okay, so number 2, student in the football stands throws a football upward. The height of the football over time can be represented by this equation. What's the initial velocity? So that comes from right here. Now, we don't know, is it meters or is it feet, but the negative 16 tells you that this is in feet per second. How far off the ground was it when it was thrown? That would be the initial height, so 24 feet. How far off the ground is the ball after 1 second? So we're going to go ahead and plug in 1 in both spots and run that through, and you get h equals 28 feet. And how long does it take for the ball to hit the ground? So we know after 1 second, it's at 28 feet. And so you could try out some other things. So let's go ahead and try, since we already have 1, let's try 3. Negative 16 times 3 seconds. Let's see what kind of number we get here. And we get a negative. So that means it's already hit the ground in the past. So let's try 2. I put the wrong numbers in. Negative 16 times 2 squared plus 20 times 2. Okay, and when I do that, so h equals negative 16 times 2 squared is 20 times 2. I get 0 on the dot, and so now I know my answer. If I get 0, that means it's hitting the ground right at that moment. It's 2 seconds. But that was just guess and check, right? I'm just grabbing numbers and trying it. What's a better way to do it? So using your graphing calculator, you're going to go to your y equals. You're going to go ahead and you're going to put this equation in, which you can see I've got right here. You use x as your variable. And then you're just going to go to your table and you can scroll around and see what's going on. So starting at 0 is at 24, it's thrown up to 28, and by 2, we're at 0, and you could pull that information straight from the calculator. So that's actually the better way to do it. Okay, number 3, toy rocket is shot upward from a 3-meter platform with an initial velocity of 100 meters per second. So now we need to make sure we don't use that negative 16. We are using the negative 4.9. So write an equation to describe the height of the rocket. So h equals negative 4.9 t squared plus the initial velocity of 100 times t plus the initial height, which is 3. How high will the rocket be after 4 seconds? We're just plugging in. And the calculator does the rest for you. And the final height there comes in as 324.6 meters.